All right, so next up is gaseous exchange. So for gaseous exchange for birds, this is one of the most important focus areas. All right, so they have extremely high oxygen demand whilst they are flying. And so to cope with this, they have lungs, and these lungs are packed very densely with little tubules. And then they also have multiple air sacs in their body cavity that is linked to those lungs. So we'll have a look at that in a minute. But important to note that to increase surface area, these tubules are very, very thin, and they also have a lot of capillaries, all right, your tiny little blood vessels, to enable lots of gaseous exchange to happen. So here, if you look at the diagram of the bird, we can label our two air sacs, our anterior air sac and our posterior air sac. Remember that anterior means towards the head and posterior means towards the end of the animal. So when the bird breathes in or inhales oxygen, its rib cage expands, and the muscles also expand to allow for this ventilation to happen. So ventilation just meaning breathing. So the oxygen enters the bird's beak and it flows through one of the tubules through a series of one-way valves. So valves have the ability to open and close, one way obviously meaning in one direction, and this allows the oxygen to be forced in one direction through the animal. All right, so it will fill up into the posterior air sac, and then when the bird breathes out again, the rib cage is contracted, so the muscles relax, and then that forces the air in the posterior air sac to be forced up through the lungs with many capillaries into the anterior air sac, so the air sac towards the head of the animal. So after it's gone from the posterior air sac through the lungs, anterior air sac, it leaves the body through the beak again. So that is your carbon dioxide. And this type of airflow and this mechanism that you see in front of me is very efficient because it allows the air to flow forward through the lungs on both the inhalation and the exhalation. So when the bird breathes in, the air is flowing forward through the lungs, and when the bird is breathing out, the air still flows forward through the lungs. And so the bird can continuously exchange oxygen and CO2 in this way.